Dear all, this is Dilip Udhani, and today I will teach you a topic of vector calculus, that is Green's theorem in a plane. So what is Green's theorem? If we have been given two functions, one is mxy and other is nxy, if these two functions are functions of x and y and their partial derivatives del m by del y and del n by del x are continuous in some region R of xy plane bounded by a closed curve C, then we have the line integral, that is integration of f dot dr along a given closed curve C, that is equals to integration of m dx plus n dy along that closed curve C, that is equals to double integration over a given region R of del n by del x minus del n by del y dx dy, where f is mi plus nj and dr is dxi plus dyj. This is called Green's theorem. This is the statement of Green's theorem. It says that the line integral of the given vector field f bar, that is equals to the double integration of del n by del x minus del n by del y dx dy over a given region R. Now we will take some examples related to Green's theorem. Example number 1, that is, state the Green's theorem and use it to evaluate the integration of 3x square minus 8y square dx plus 4x minus 6xy dy, where this C is the boundary of the region defined by y equals to x and y equals to x square, right? We have to find out the integration of this function along a closed curve C bounded by y equals to x and y equals to x square. Before that, we have to write down the statement of Green's theorem, and that is already discussed with you people, right? This is the statement of Green's theorem. Okay. Now first of all, what we have to do, compare this integration 3x square minus 8y square dx plus 4x minus 6xy dy with the standard form of integration m dx plus n dy. So we will be having the functions of m and n in terms of x, y. So we have m equals to 3x square minus 8y square and n equals to 4x minus 6xy. So first of all, we have to find out partial derivative of m with respect to y and partial derivative of n with respect to x. So del m by del y, that is equals to derivative of 3x square is 0 and y square is 2y. So 2 8 just 16, and before 8y square we have minus sign, so it will become minus 16y. Similarly, del n by del x, so derivative of 4x is 4 and minus 6xy is 6y. So we have del n by del y equals to minus 16y and del n by del x equals to 4 minus 6y. Now we will use the Green's theorem, and by Green's theorem we have integration of m dx plus n dy along the given closed curve C, that is equals to double integration of del n by del x minus del n by del y dx dy over a given region R, right? Here the given region R, that is the region bounded by two curves. One is a line y equals to x. Line y equals to x is nothing but a line passing through origin, and other is the parabola y equals to x square. So the boundary region by the line y equals to x and the parabola y equals to x square, that is this one. Okay. Now replacing del n by del x by 4 minus 6y and del n by del y minus 16y. So minus minus will become plus 16y, and this is dx dy. Now we have to integrate this function, right? But before that, we have to find out the limits of integration. So you can find out the limit of integration with the help of this region. So first of all, we will take outer limit. So how to select outer limit? You have to find out the vertical limits or vertical lines right? Such that this whole region will be covered, right? If you will consider this line, this is x equals to 0 line, and this is the x equals to 1 line. So the whole region, that is this one, is bounded between two lines. One is x equals to 0, another is x equals to 1. So the outer limit that will be integration from x equals to 0 to 1. Now we have to take inner limit. Here we are taking outer limit of x and inner limit of y, right? You may take outer limit of y and inner limit of x also. Okay. So the outer limit, that is of x, and that is from x equals to 0 to x equals to 1, right? Now the outer limit of x and the outer limit is of x, right? Okay, and that is the vertical lines. So you have to take a strip along this region that will be in vertical form, right? And if this strip will touch the bottom curve, you can see it touches this curve at this point, right? And this line at this point. So your limit of y, that is inner limit of the integration, will vary from y equals to x square to y equals to x. Hence we have written integration from y equals to x square to y equals to x, right? Now we have to integrate this function, right? First of all, we will integrate with respect to y. Okay, now this 4 as it is, minus 6y plus 16y, that is 10y. Now integration of 4 with respect to y, the result is 4y, and 10 as it is, integration of y with respect to y is y square by 2. The upper limit is x and the lower limit is x square. First of all, replace y by x, so it will become 4x plus 10 upon 2, the result is 5, and x square minus, replace y by x square, so it will become minus 4x square minus 5 x square, the whole square, it will become x raised to 4. Now 4x as it is, right? Then after plus 5x square minus 4x square, the result is x square, and minus 5x raised to 4 as it is. Now we have to integrate this function with respect to x. So integration of x is x square by 2, x square is x cubed by 3, and x raised to 4. The result is x raised to 5 by 5. So 4 upon 2 is 2, and 5 will cancel out. Now the upper limit is 1 and the lower limit is 0. Put down the value of upper limit 1, and for lower limit it will become 0. So we have 4 by 2 is 2, 1 square plus 1 cube by 3, minus 5 will cancel out, 1 raised to 5, the result is 1. Now simplify this result, overall answer is 4 by 3. So the integration of the given function, that is this one, along a closed curve C, which is the region bounded by the line y equals to x and the parabola y equals to x square, is 4 by 3. Okay. Now we will see example number 2. Here we have to verify the Green's theorem for the integration of this function, where C is bounded by the region x equals to 0, y equals to 0, and x plus y equals to 1, right? So from standard form, integration m dx plus n dy, we have m equals to 3x square minus 8y square, and n is 4y minus 6xy. So first of all, we will find out del m by del y and del n by del x. So del m by del y, that will be minus 16y, and del n by del x, that will be minus 6y. Now draw the region x equals to 0 means y axis, y equals to 0 it means x axis, and x plus y equals to 1 line, that will be like this. If we will put down y equals to 0, the result will be x equals to 1. So this line will intersect x axis at the point 1, 0, and if we will put down x equals to 0, we have y equals to 1. So this line will intersect y-axis at the point 0, 1. So this is the bounded region. Here we have to verify the Green's theorem. So for that purpose, what we have to do, we have to find out the line integral along this path, along the path OA, then after along the path AB, and finally along the path BO. Then after we have to add all these three results. So that will be the left hand side, that will be integration mdx plus ndy along the given closed curve C. Then after we have to verify the Green's theorem, right? So we have to find out the double integration of this function along the given this region, this boundary region, right? And then after we will see whether both the results are same or not. Okay. So first of all, we will find out the line integral, integration of mdx plus ndy, that is equals to integration of mdx plus ndy along the path OA plus integration of mdx plus ndy along the path AB, then after integration of mdx plus ndy along the path BO. So first of all, we will find out this one, right? Integration of mdx plus ndy along the path OA. So path OA is an x-axis, and x-axis means y equals to 0. So we have dy equals to 0, and x will vary from 0 to 1. You can see that this point is 0, 0, right? And this point is 1, 0. So y equals to 0 is fixed, and x will vary from 0 to 1. So we have x vary from 0 to 1. So the given integration mdx plus ndy along the path OA, that will be, right, what we have to do, you can see over here 3x square as it is, replace y by 0, 3x square as it is minus 8y square dx plus 4y minus 6xy dy, 3x square as it is and 8y square, y is 0, so replacing this by 0. Then after 4y, so y is 0, replacing this by 0, and dy is 0. So this term overall will become 0, and x will vary from 0 to 1. So we have only one term, that is 3x square dx. Now 3 as it is, and the integration of x square, the result is x cube by 3, and the limit is from 0 to 1. So for upper limit 1, it will become 1 cube by 3, and for lower limit 0, it will become 0. So 3 will cancel out, the result is 1. Now similarly, we have to find out the line integral of the given function along the path AB. And the path AB, that is nothing but the line x plus y equals to 1. You can see that is the line x plus y equals to 1. So we are making the subject of y over here, so it will become y equals to 1 minus x. So we have dy equals to minus dx. Okay, dy equals to minus dx. So what we will do, we will replace dy by minus dx and y by 1 minus x in this function. So we are going to integrate with respect to x. So we have to see how x will vary, right? Here x is 1 and here it is 0. So x will vary from 1 to 0, right? So x will vary from 1 to 0. X will vary from 1 to 0. So integration from 1 to 0, 3x square as it is minus 8 as it is, and replace y by 1 minus x, so it will become 1 minus x the whole square. Then after dx as it is plus 4 into bracket y is 1 minus x minus 6x as it is, and y is 1 minus x, and dy is minus dx. Now you have to simplify this only, right? You have to apply the formula of a minus b the whole square over here, and then after you have to multiply the result by 8, right? And over here you have to multiply 1 minus x by 6x and 1 minus x by 4, and then after you have to simplify the result. Okay, right? Or you can directly integrate the function 1 minus x square. Okay, here 3 as it is, integration of x square is x cube by 3, and integration of 1 minus x the whole square is 1 minus x the whole cube by minus 3, and this constant as it is. Similarly, minus 4, integration of 1 minus x is 1 minus x the whole square by minus 2, and then after 6 as it is, and integration of x is x square by 2, and the integration of x square is x cube by 3, and the limit is 1 to 0. So first of all, you have to put upper limit 0, and that is this one, and for lower limit 1, that is this one, and finally you have to simplify this result. You will be getting value 8 by 3. Now we have to integrate mdx plus ndy along the path BO, and along the path BO, the path BO is nothing but y-axis, that is the line x equals to 0, so we have dx equals to 0. So x equals to 0, so definitely y will vary from 1 to 0. So you can see over here y will vary from 1 to 0. This is y1, and over here this point is 0 0, so y will vary from 1 to 0 and x is fixed 0. Okay. Now along the path BO we have x equals to 0, dx equals to 0, y will vary from 1 to 0. So replace x by 0 over here and dx by 0. So first term will become 0, x is 0, so this will become 0. So we have only 4y, and the limit is from 1 to 0. Now integration of y is y square by 2, upper limit is 0 and the lower limit is 1. So it will become 0 minus 1, and 4 by 2 is 2. Okay, so the result is minus 2. Now the integration of mdx plus ndy along the closed curve C, that is along the path OA, then after AB, and this is along the path OA, this is along the path AB, and this is along the path BO. Now, right? Now adding all the three results, we have pi by 3. Now we will apply Green's theorem, double integration of del n by del x minus del n by del y dx dy along the given region R, that is double integration. You can see over here double integration over the given region R, that is del n by del x minus del n by del y. So del n by del x minus del n by del y. So del n by del x. So del n by del x is minus 6y. This minus sign as it is, and del n by del y is minus 16y. You can see over here, right? Del n by del y is minus 16y and del n by del x is minus 6y. Okay, right? Minus 6y and minus 16y. So minus minus plus 16y minus 6y, the result is 10y. Okay, now you have to write down the limits of x and y, right? So first of all we will select the limit of x, and we are considering here the outer limit of x, so that will be x equals to 0 to x equals to 1, right? See, you can see that x equals to 0, the integration is from x equals to 0 to x equals to 1. So this is the outer limit. How to select outer limit? We have to consider two vertical lines such that the whole region will be bounded by these two lines. Okay, so one is x equals to 0 and other is x equals to 1. And for inner limit you have to draw a vertical strip like this, right? And this vertical strip touches the bottom at point y equals to 0, and its top is going to touch this line at point here, and it means it touches the line x plus y equals to 1. So from here you have to make the subject of y, so that will be y equals to 1 minus x. So the inner limit of y will vary from 0 to 1 minus x. Okay, now we can see over here x will vary from 0 to 1 and y will vary from 0 to 1 minus x. Now integration of y is y square by 2, and the inner limit is 0 to 1 minus x. Replace y by 1 minus x first, then after for lower limit it will 0, so we have only 1 minus x square. 10 by 2 is 5. Now integration of 1 minus x square with respect to x, the result is 1 minus x the whole raised to 3 divided by minus 3. Now upper limit is 1 and lower limit is 0. For upper limit 1 it is 0, and for lower limit 0 it is 1 minus 0 is 1. 1 raised to 3 is 1, right? And this will become minus 5 by 3, and 0 minus 1 is minus 1. So minus 1 into minus 5 by 3, result is 5 by 3. Hence you can see that from equation 2 and 3 the Green's theorem is verified. Now similarly we have to verify Green's theorem in case of example 3 for this function, right? For this function, and the reason are bounded by the unit circle, that is r of t equals to cosine of ti plus sine of tj, and where t will vary from 0 to 2 pi. 0 to 2 pi. Now the line integral f dot dr bar, that is equals to x minus integration of x minus I cap plus xj cap, and dr bar is nothing but dxi plus dyj. Now finding the dot product of these two vectors, we have I dot I is 1, j dot j is 1. So we have x minus y dx plus x dy. Now if you will compare r of t equals to cosine of t I cap plus sine of t j cap, right, with r equals to xi plus yj, we have x equals to cos t and y equals to sin t. If x equals to cos t, we have dx equals to minus sin t dt, and y equals to sin t, we have dy equals to cos t dt. Now integration will be from 0 to 2 pi. Why it is from 0 to 2 pi? Because the limit of t is given to us, that is integration from 0 to 2 pi. So this line integral, right? This line integral, that will become, you have to replace x by cos t, y by sin t, and dx by minus sin t dt, right? And then after y by sin t, dy by cos t dt. So this line integral, right? The line integral of this function, okay, right, that will be converted in terms of t, and we have to take the limit of t, that is from 0 to 2 pi. So we have taken limit integration from 0 to 2 pi, and this is c cos t minus sin t, right? This is cos t minus sin t, okay, cos t minus sin t, and dx is minus sin t dt. Then after plus x dy, and x is cos t and dy is cos t dt. You can see cos t dt. Okay. Now cos t into minus sin t, result is minus sin t cos t, minus minus plus sin t into sin t to become sin square t, plus cos t to become cos square t, and cos square t plus sin square t, the result is 1. Multiply it by 2 and divide it by 2. So 2 sin t cos t will become sin 2t, and in the division we have 2, right? Now integration of sin 2t, the result is minus cos t, 2t by 2 and minus 1 by 2 as it is, and integration of 1 with respect to t, the result is t. The upper limit is 2 pi, right? So this is minus minus plus, this will become 1 by 4. If you will replace t by 2 pi, so the result is cos 4 pi, t by 2 pi, so it is 2 pi. Then after 0, right? So minus minus plus 1 by 4 and cos 0, and replacing t by 0. Okay. Now 1 by 4 as it is, cos 4 pi, its value is 1, 2 pi as it is, cos 0 is 1. So this is minus 1 by 4. Minus 1 by 4 plus 1 by 4 will cancel out, and the result is 2 pi. So we have gone through the line integral f dot dr bar, and its result is 2 pi. Now we will find out this double integration. Okay, so we have been given function of x y is x minus y I cap plus x j cap. So comparing this with mi plus nj, we have m equals to x minus y and n equals to x. So del m by del y is minus 1 and del n by del x is 1. So the double integration over the given region R, del n by del x minus del n by del y dx dy equals to double integration over the given region R, del n by del x is 1 and del n by del y is minus 1. So minus minus plus 1. So it will become 1 plus 1. So 1 plus 1 is 2. So we have double integration over the given region R dx dy, and the given region R, that is a unit circle, right? So geometrically double integration dx dy represent the area, right? So this represent the area of a circle, because the closed path given is a unit circle, and the area of circle, that is pi r square, and as it is a unit circle, so the value of r is 1, so it will become 1 square. So pi as it is, 2 as it is, so the result is 2 pi. So from equation number 1 and 2 we can say that the line integral f bar dot dr bar or integration of n dx plus n dy along the closed curve C, that is equals to double integration of del n by del x minus del n by del y dx dy over the given region R. Hence, Green's theorem is verified. Thank you for watching this video.